Quadratics, modelling and the discriminant. These are the three things I'm going to go through in this video. Good morning, ladies and gentlemen. I hope you're having a fabulous day so far. Today I'm going to be going through chapter 2 of AS Maths. So it's like the first topic you learn about when you get into year 12. I'm going to show you the hard questions, the easy questions, the in-between questions, and we're going to go through how you're going to get that A star and get a massive, monumental head start over every other Tom, Dick and Harry in your class. Let's go, ladies and gentlemen. Before we get started, remember to like, subscribe and share, and let's get into the video. Okay guys, let's get into it. So if we think about the formula of a quadratic, it's ax squared plus bx plus c, isn't it? Now, the discriminant is basically a tool that we use to deduce how many roots a quadratic has. So if we had this quadratic, okay, where it's not got any roots, b squared minus 4ac, which is the discriminant, would be less than 0, okay, so it would be negative. If we had this quadratic where it only has one root, and I'm going to try and be careful when drawing this, okay, so it's got one root, b squared minus 4ac is equal to 0, okay, and if it has two roots, okay, then that means that b squared minus 4ac is greater than 0. And what is b, what is a, what is c? Well, it's all relative to this equation, okay? Hopefully we've got that out of the way from the start. Let's get into a question then. F of x is equal to 4k x squared plus 4k plus 2x plus 1. So if we put this in the format ax squared plus bx plus c, we know that the a is equal to 4k, okay? You don't involve the x's. The b is equal to 4k plus 2, and the c is just equal to 1, so it's pretty easy in this scenario. Okay, so we need to work out b squared minus 4ac. So that would be 4k plus 2 squared minus 4 times 4k times 1. Okay, that's equal to 16k squared plus 16k plus 4 minus 16k. Okay, and ladies and gentlemen, what you can see is that the 16k's cancel out. So what that means is the answer is 16k squared plus 4. Okay, now we've got the part B, which is by simplifying your answer to part A or otherwise, prove that f of x has two distinct real roots for all non-zero values of k. So we know that this k squared is always going to be positive. So discriminant is always going to be greater than 0, essentially, because since when we factorize it, it's going to be equal to 4 brackets 4k squared plus 1. And we know k squared is always positive. Hence, we know that b squared minus 4ac is greater than 0. Hence, it has more than one root. Explain why f of x cannot have two distinct roots when k is 0. We've got to now go back to the original equation, which is this equation. And we've basically got to substitute in k is 0, sorry. So when we substitute k in 0, we get 4 times 0. So that is equal to 2x plus 1. Okay? And we know, ladies and gentlemen, that 2x plus 1 is a linear, isn't it? It's something like that. So that means that it only intercepts the x-axis once. So when k is 0, f of x is equal to 2x plus 1, which is linear. Hence, it only has one root. Okay, ladies and gentlemen, that is full marks on this first question. Okay, let's move on to the next question. So, using algebra and showing each stage of your working, find all real solutions to the equation 2x plus root x minus 6 is equal to 0. Okay, let's go. This is an example of what we call a hidden quadratic. So, we can rewrite this as 2 times root x squared, okay, because we know root x all squared is equal to x, plus root x minus 6 is equal to 0, okay. Now we can rewrite the root x as another variable. We can call it y. So 2y squared plus y minus 6 is equal to 0, okay. Now we factorize this quadratic. Okay, so when we factorize it, we get y plus 2 times 2y minus 3 is equal to 0. So we set y equal to negative 2 and y equal to 3 over 2, okay. Now, y is equal to negative 2 it won't count, because essentially when we substitute root x for equaling y, well, obviously you can't have the negative number there. So we make 3 over 2 as our answer, and therefore root x is equal to 3 over 2. Therefore x is equal to 9 over 4. So the answer to that question is 9 over 4, ladies and gentlemen. Okay, so next, moving on. X to the 8 minus 17x to the 4 plus 16 is equal to 0. Now, the way we can find a hidden quadratic in this scenario is by setting x to the 4 equal to y. So x to the 4 squared minus 17x to the 4 plus 16 is equal to 0. Okay, so if we set x to the 4 equal to y, then we get y squared minus 17y plus 16 is equal to 0. Then when we factorize that out, okay, so we get y minus 16 and y minus 1 is equal to 0. Then that means that y is equal to 16 and y is equal to 1. So we know that y is equal to x to the 4. So if x to the 4 is equal to 16, then that means x is either plus or minus 2. And if x to the 4 is equal to 1, then that means x is equal to plus or minus 1. So the answer is 1, negative 1, and 2, negative 2. And that, ladies and gentlemen, is that question done. Let's start this modelling question. Modelling is when we use mathematics to represent a real life scenario. This is a diver jumping off a springboard. Let's go. A diver launches herself off a springboard. The height of the diver in meters above the pool t seconds after launch can be modelled by the following function. H of t is equal to 5t minus 10t squared plus 10. How high is the springboard above the water? So if we draw a diagram of this illustration, essentially, so we'd get, okay, so this is the springboard, this is the diver, and then obviously this is the trajectory. And then let's say that's the lovely sea or the swimming pool, whatever. How high is the springboard above the water? So essentially that is when t is 0. Okay, so when t is 0, we sub it in and then we get 10 meters. Okay, so 10 meters, because essentially when t is 0, that is when the diver hasn't even jumped yet. That's when they're just stationary at the springboard, and that's what we want. Okay, so let's move on to B. Use the model to find the time at which the diver hits the water. So the diver hits the water when the height is 0, okay, because it talks about the height above the pool, and obviously if there's no height above the pool, if it's 0, then that means they've hit the pool. Okay, so let's make 0 equal to minus 10t squared plus 5t plus 10. Now we have to use a quadratic formula for this one, so negative 5. Okay, now the value when we make it negative, so when we get minus 5 minus square root of 5 squared, blah blah blah, that gives us 1.28 seconds. Okay, so we get 1.28 seconds, and obviously you can't get a negative value for the time, so we take the positive value. Right, there we go, part A and B done. Now, what this asks us to do in part C is complete the square. Now, completing the square can prove extremely useful for modelling questions because it enables us to find the turning point. That could be a maximum or it could be a minimum. In this case, I believe it's a maximum, okay, because it's like it goes like that. So rearrange it into that form. So obviously we've got our equation. So for C we've got minus 10t squared. I believe it was plus 5t plus 10. So we can factor out minus 10. Minus 10 brackets t squared minus 0.5t plus 10. Then we complete the square. So minus 10 brackets t minus 0.25 minus 1 over 16 plus 10, and then we times that, so we get minus 10 brackets t minus 0.25 squared minus 1 over 16 times minus 10 is plus 5/8, so plus 5/8 plus 10, then we get minus 10 brackets t minus 0.25 squared plus 10.625 meters. Okay, so what do we do for part D? Using your answers to part C or otherwise, find the maximum height of the diver and the time at which this maximum height is reached. So we know that this value is going to keep on getting smaller and smaller and smaller as t goes up. So hence the maximum height is 10.625 meters, okay? Is equal to 10.625 meters. Now the only way that that could happen is when this whole entity is equal to 0. Okay, and it's equal to 0 when t is 0.25. When t is equal to 0.25. And that, ladies and gentlemen, is how you answer that modelling question. Surprise! I have another hidden quadratic question for you. Let's go. The function f is defined as f of x is equal to 2 to the power of 2x minus 20 times 2 to the x plus 64. Can you spot the hidden quadratic? Okay, well, I can rewrite that as 2 to the power of x all raised to the power of 2 minus 20 brackets 2 to the x plus 64. Give it a go now. Essentially, we can make 2 to the x equal to y. Hence, we can write this as y squared minus 20y plus 64. Okay? Hence, y minus 16 times y minus 4 is the way it can be factorized. And we know because y is equal to 2x, that means that 2 to the x minus 16 and 2 to the x minus 4 is the answer. Okay? Hence, write down the two roots of f of x. So 2 to the x could equal 16, where x is equal to 4, or 2 to the x could equal to 4, where x is equal to 2. And that, ladies and gentlemen, is the answer. Well done for making it this far, ladies and gentlemen. This is the final question I have in store for you. It's a massive modelling question. It's not very difficult, but when you look at it, there's just so much writing that you just stand there stagnant as if a stun grenade hit you. So have a go at this question. Lynn is selling cushions as part of an enterprise project. On her first attempt, she sold 80 cushions at the cost of 15 quid each. She hopes to sell more cushions next time. Her advisor suggests that she can expect to sell 10 more cushions for every £1 that she lowers the price. The number of cushions sold, C, can be modelled by the equation C is equal to 230 minus HP, where P is the price of each cushion and H is a constant. Determine the value of H. So we just substitute the values that they've given us. Okay, so C is the cost. Okay, of so C is the number of cushions sold. So we know that the number of cushions sold is 80. So 80 is equal to 230 minus HP. What's P? £15 each. So minus 15H. Okay. Then we get 15H is equal to 150. So H is equal to 10. Okay, and that is the answer for part A. To model the total revenue, R pounds, Lynn multiplies the number of cushions sold by the price of each cushion. She writes this as R is equal to P times 230 minus HP. So we know H is equal to 10, so we can just sub that in. So R is equal to P brackets 230 minus 10p. Alright, there we go. So, therefore we can write it as R is equal to 230p minus 10p squared. Okay, so now we need to complete the square. So we know that completing the square is already extremely useful in modelling because obviously it gives us a turning point. Remember, they won't tell you to complete the square each time. Sometimes you just got to know it off the bat that, okay, I need to complete the square. Remember, if you have a modelling question and you don't know what to do, it's more likely than not that you have to complete the square. Okay, so let's factorize out minus 10, okay, and then times that by p squared, okay, and then multiply that by minus 23p, okay, because minus 10 times minus 23p forms 230p, okay. Now what do we need to do? Minus 10 brackets p minus 11.5 squared. I don't know what 11.5 squared is, I'll just use my calculator. 11.5 squared is equal to 132.25, so minus 132.25, and then close the brackets. Now we need to multiply this by minus 132.25, so we get positive 1322.5, so minus 10 brackets p minus 11.5 squared plus 1322.5. That is the answer, ladies and gentlemen. Okay, let's see what we need to do now. Using your answer to part B or otherwise, show that Lynn can increase her revenue by £122.50 through lowering her prices. State the optimum selling price of a cushion. So initially her revenue was 80 at the cost of £15 each. So if we do simple maths, what's 80 times 15? 1,200. So we know that 80 times 15 is 1,200, okay? And essentially, the maximum that this could be is 1,322.5. So the maximum price. When we do 1,322.5 minus 1,200, we get 122.5. So obviously, they've told us that that is the correct difference. 50 minus 1,200 is equal to £122.50. Okay, fair enough. Now what do we need to do? Essentially, we need to find the value for when it's a maximum. So we know as the value of p increases, this becomes lower, okay? So we need to find a value for when the entire term is 0, and that is none other than when p is 11.5. So when p is 11.5, it's a maximum, okay? And when the difference of them is found, it's £122.50. And that, ladies and gentlemen, is how you do the final modelling question. I hope you enjoyed the video. Please do leave a thumbs up, subscribe, and if you have any comments that you'd like to share, put them in the comment section down below and I'll try my best to help. Thank you for watching.